So we're going to do a quick presentation here, present for around 20 minutes, and then we'll open up for Q&A at the end for the last 5-10 minutes. So by way of introduction, I'm Beth Stockham. I work at Databricks. I work with Chris at Aggreko. Chris Wallace here. I'll let you introduce yourself more formally, but lead data scientist at Agreco. For anyone that doesn't know of Aggreko, they are a global business supporting over 100 companies with power, supply, heating and cooling products. So I'll hand it straight over to Chris, let you do a little bit more of an introduction about yourself and your role within Aggreko.
Perfect. Thanks, Beth. I think we've got one set of headphones at the front not working, but we'll carry on. Okay. So thank you everyone for coming. I know we're in the data engineering room, and I'll give you a warning up front that I'm a data scientist by trade, so expectations be managed. But today I'm just going to chat you through some of the platform that Agreco have built to do their asset management on their fleet of assets around the world. So intro from me, my kind of background originally from academia, through physics, engineering, and found my way into data science, and now at Agreco. As an organisation, we have offices all around the world, service centres, maintenance and repair. Our technology centre is based up in Glasgow, just up the road in Scotland. 7,000 odd employees, and as Beth mentioned, primary business for us is temporary power generation, cooling and heating. So something of the order of 10 gigawatts of power generation and thousands of assets, 10, 15,000 assets in the fleet any given time. So you can see on the map just now, which is slightly out of date, the service centre locations around the world. So as a technology service based out in the UK and out of Glasgow, we support all of the customers and operators of the equipment, and that might be Aggreko or it might be long-term contracts with third partners. So what is data science at Aggreko? So three main streams that we work through are asset management, so looking at the generators, the heaters, the chillers, monitoring them, looking at parameter data, typically time series, understand when components are going to break, when assets are going to degrade, and then anticipate when these things are going to happen so that we can go in, make repairs, make replacements of parts to save money, improve reliability, and make everything better. The second stream is kind of business analytics, where we look at serving internal customers within the company, so looking at optimising fleet movement, revenue forecasting, identifying pricing and supporting sales activities within the business. And then the final section is energy transition. So primarily the Aggreko fleet just now is diesel, gas, but starting to move towards hydrogen, solar, battery, hybrid sets of power to augment and reduce the carbon emissions and other types of emissions that come out of the fleet. So that's a huge part of the business for us, to reduce our footprint, but also for our customers who are looking to have the same service, the same availability, the same capability, but not have the same impact on the environment. So, as I mentioned earlier, a kind of global challenge for us, a relatively small team in Glasgow of data scientists and data engineers, and we support these thousands of assets at scale, and some of these are in completely remote locations, so you might be in the outback in Australia, you might be in the middle of Africa without any telecoms, any satellite connection, and providing the condition monitoring or asset management capability to these assets out in the field. So Agreko's data science team is now small still, but well established, and working directly with the engineers, we've managed to take these asset management insights and realise savings kind of the order of millions of pounds per year. And that's through avoided failures, that's through tracking and planning maintenance better, and reducing downtime to customers, so we provide the service that they expect. So generally speaking, and this varies asset to asset, the asset will stream data through a modem up into the cloud, through a mobile network, or in some cases a satellite connection, into the cloud, ingested by a bunch of different systems. Then through our data lake appears and gets cleaned, and things are added and removed, and then provided to the data team, who can then work with the engineers to build models, alarms, analytics on top of that. And then these are served out through tools like Power BI or the types of things I'm sure you've seen at every exhibition stand out here today. So these are automatically integrated with our asset management system, so not just dashboards that people can play with. Emails, phone calls, text messages will go directly out to engineers in the field. Somebody jumps in a van, grabs a toolkit, goes out, repairs something, replaces a fuel filter, and then we can realise tangible financial benefit from doing this. So
Great, thanks so much for that, Chris. So Greco's obviously been on a bit of a journey recently, building out your new modern data platform. So maybe you can talk to us about the underlying infrastructure and some of the tools that you and the team are working with.
Yep. So in terms of data infrastructure, so Aggreko is a company that's been around for decades, so this is not a startup that's appeared and a huge amount of data to work with. Initially, people talked about Agreco within the company as a generator business that also has some data, and now there's a growing number of people in the company who like to think of it as a data company with generators as well. So that's a wee bit cliched, a wee bit twee, but the idea is we've got 15,000 generators, assets around the world, streaming every second, every minute into the cloud. Really quickly that adds up. So in terms of platforms and tools that we use, we have kind of bespoke tools for the asset management side of things. So this has existed before the cloud, before data science. Collecting data, looking at data, analysing trends. Engineers have been doing this for decades. So we've got these systems, and then on top of that we have kind of ingestion tools. So your Prefect, your Databricks, Kubernetes, whatever it is, dragging that data out of bespoke databases for specific purposes like asset management, putting it into the data lake for us, and then combining that with all the commercial and ERP type tools, so your Salesforce or Cloud Suite or any of a number of different tools that we use. And then when that's all in the data lake, so we're mostly an Azure business, working with Databricks obviously, that's made available then to data science teams, the BI teams, the data engineering teams, and we build tools on top of that layer. So a couple of diagrams at the bottom are logos you can see, so typical kind of Python stack mostly for what we do. We have teams that work directly with Power BI who build dashboards for specific activities, but the kind of core of the data science that we do is working with the engineers, so sitting down in a room, or more typically recently teams, for a couple of hours with an engineer and getting a solid understanding of the engineering problem, and then coding something up. And that might be a model, or it might be a machine learning tool, or it might just be code that handles the logic that the engineer was applying anyway. Building these models and then deploying it through CI/CD, DevOps, all these magical tools into the cloud, primarily through Databricks.
So it might be a little bit of a shameless plug here, Chris, but can you talk to us about what made you choose these technologies? Why was it Azure and Databricks as a platform of choice?
Yeah, so eventually all the data that we had we kept on a on-prem service, and that becomes a huge overhead to manage and track and maintain. So we started a movement to the cloud, but at the same time we had teams looking at data science for data that we had available, and what we found was that we could use Databricks for the kind of orchestration, the ingestion side of things with tools like Prefect, but our data scientists and data engineers were already using Databricks and other Spark type tools to do their analysis, so it seemed like a bit of a no-brainer then to be using the same tools, the same platform, and bring that all together.
Thanks, Chris. I'll
There's your plug.
buy your pint later. Brilliant. So you've got your platform set up, you're ready to go. Can you talk to us a little bit about the use cases that you're driving with this platform and how you've got the business on board with that?
Yep. So hopefully the next couple of slides maybe make this a little bit more tangible. So the kind of one of the core activities that the data science team do is around this condition-based alarm, so asset management for the fleet. As I mentioned earlier, usually the best way of doing this, if you're an engineering company, you could hire a data scientist team and you could give them all your data and you say, go away and find me some interesting things, and they'll come back with some trivial correlations or some totally meaningless correlations, or maybe even some things that are useful. But by far the best way to do this is to just talk to them and understand the problems, the things that they realise, their gut sense of, we know that this system is related to that system, and if we see a failure here, it will propagate down to here. So the lowest hanging fruit in that sense is to talk to them, get their knowledge, and put that into code or into models and implement it. So that's what we'll do. We'll sit down with an engineer, figure out what the problem is, what the data associated with that is, build some tool, some model, some insight, and then iterate that with the engineer to get value and make sure that it's something that's going to be useful. we build something and then there's no value to the engineer, like the actual engineer at the end, there's no point in progressing it because it's not delivering value. It's going to cost you money, in Databricks to run it. So we go around that process until we make sure we've got something that's useful. The model itself, we've got a set of environments. We've got a dev environment, a pre-live environment, and a live environment. And we can have the code in each of these for a certain amount of time, depending on how important it is, or what kind of insights or dependency we're going to have on it. And we can run this and do it autonomously, so set it up to run every day, every hour, every minute, depending on the use case. And there's a bit of kind of nuance here because some of these engineering activities you may not care about checking every minute or every hour, but if you do it every day or every week, that's important, and that can help you save money in terms of the cost of spinning up clusters and putting code running that you don't necessarily need to have. And then eventually we're happy with the model. The engineer agrees, signs off, and we work out a process for taking their feedback live as the model runs, and then we deliver that model into the cloud environment, into the live environment. That is so a very, very basic diagram compared to, I'm sure, some of the diagrams you've seen in the last couple of days. The asset data streams into the cloud. The model runs in the cloud, processes the data to whatever schedule. Insights are generated by the model, the code typically run in Databricks, and then is sent out directly through the asset management system that already exists. So through that way, the engineers can get their text message or the phone call or email or whatever it is and action it straight away. And it gives us great visibility of which alarms are running, which ones have failed, how many alarms have failed, how many alarms have triggered. And then there's a whole separate challenge there about making sure that you're achieving what you need to achieve in doing the analysis, that you're not essentially overkill in terms of running the analysis more than you need to. And also that a much harder problem is making sure that your analysis is giving you honest results back. It comes back and says, oh, nothing this time, that's completely fine, you can ignore it. But perhaps it's a silent failure and something slipped through the cracks. So something we're starting to work on is this pipeline of how we integrate that a bit better to understand what we'd expect to see as well as what we do see.
Great. I know you've got a couple of other examples of use cases in your deck for anyone that's interested after, but how do you go about prioritising these use cases and what's the business value that it's driven for Aggreko?
Yeah, so I think I've mentioned already is primarily looking at what's easiest to deliver value quickly. So you could find a huge problem that's really complicated that you think might give you money back in a year or 10 years. But in practical terms, you can usually sit down with an engineer and within an hour or 2 hours quantify if we could avoid this many failures per year. Not all failures, maybe 50% of the failures, and that will translate into $500,000 a year saving. Well, you do that and then you can add that on and then you can incrementally put these things together. So just now we've got about 30 different alarms running in the cloud that do this continuously for different things. So some of them are quite small. A fuel filter's clogged, go and repair it, that's fine. Others, a chiller is experiencing some issues, go and repair that, but that one's $50,000 to replace, so it doesn't take that long for these things to add up over the course of a year.
Perfect, thank you. So you've made great progress so far as a company. Maybe you could tell us a little bit around some of the challenges of scaling these models and what's next for Aggreko. What are you most excited about in the next 12 months?
Excellent, yeah. So this is where I stop talking about what we've done and start complaining and asking for ideas. So probably the biggest problem for us near term, next 6 or 12 months at least, is going to be scaling and managing the models. As I mentioned, we've got kind of 25, 30 alarms running that are really successful, providing real value to the engineers, to the company. But obviously if you get a fixed size team, if you get 25, 30 alarms and data's changing or schemas are changing or something else is changing further upstream or downstream, it takes time to maintain these, so that load kind of builds up. The more alarms, the more success you've got, also the more overhead you've got. So managing this large number of models is definitely a challenge and something we're starting to look at just now. And also ensuring there's kind of consistency and compatibility between something we developed last year and something we developed in 3 years. And where we can, obviously you want to reuse code, reuse models, but a lot of what we do is sort of bespoke to a particular engineering problem or a business problem even, that it doesn't fit the mould of a nice neat TensorFlow or scikit-learn model that the MLOps platform that I'm sure I can get if I went outside. I could drop that in and then it would monitor it for me and that would all be perfect. it seems a bit more complicated than that. And we're in the process of understanding, is every problem that's like this an MLOps problem, or is it just an improved CI/CD problem, or are there other scaling tools that we don't know about yet? So yeah, keen to seen a few interesting things in the last couple of days that have given me a few ideas, but this idea of scaling, I think for a lot of organisations where you're not meeting the mould of what everybody else, well, what most people use, it definitely adds a lot of load. So yeah, I mean, extending out from that is how you do that scaling. So just now, the models that we deploy, we use a kind of pipeline, DevOps, CI/CD, put things into the cloud through the environments and test. But at a certain point, that starts to become something outside of the core data science kind of activity for our team. Just now we've got teams that kind of blur between data engineering, data science teams, and there's a bit of overlap in skill set. So understanding the divide there is something that we're starting to formalise a bit more. But the key around that is the domain knowledge, so how our pipelines are architectured, how we maintain that, how we store that, and also just the engineering knowledge that sits underneath that. You don't want to have to read through somebody's code from 5 years ago to understand why does this model work the way it does. Even if it's commented brilliantly, that knowledge has to be kind of structured somewhere. There's a great talk earlier on from Stack Overflow talking about the best way to maintain a lot of this stuff is through Q&A. And I really like that as an idea, but I worry about coverage of everything that we do. But yeah, definitely a challenge for us. And then the last one is around kind of orchestration and monitoring. So orchestration, I think we've kind of probably got reasonably solved with Databricks, Prefect. We can spin up the capacity and the resource that we need for tasks. Tracking models, a bit more difficult. We'll get model ops type tools where we can see, you can tell me what mean average errors or precision is over time. But if what I want to find out in terms of monitoring is a bit more nuanced, I want to find out how many of these alarms weren't false positives, but they were kind of pretty close. So a failure of an asset, a generator or a component won't often be a discrete, this has failed. It might be somewhere on that degradation path. How do I quantify that, track that, and understand if the model did what it was meant to do, or if it's too early, or if it's too late, and how I refine from there. And then by far and away the biggest one for us is the silent failures. So nominally as an asset management problem, if you've got a bit of software that helps you with that, you would hope over time your number of failures would go down, so your number of alarms would also go down. But your number of alarms could also go down because your code stopped working. So how do you decouple the improvement you're realising from what you're doing from some problem that you don't even understand because you don't have visibility of it? And I'm sure there's data observability tools that can help with that, but sometimes engine manufacturer might change something subtly, or a data pipeline might change in a very subtle way that means that the model doesn't work anymore. And yeah, it's a big challenge for us.
Great, thank you so much. It's really exciting to see the journey that Greco's on and the progress you've already made. So last question from me. Obviously everyone in this room is at different levels of maturity, starting from different points. What would be the one piece of advice you could offer to somebody in your role just starting out?
Yeah, so I realise I've got no idea about anybody's background or what anybody's doing. So with that in mind, the best bit of advice I would give to anybody doing a similar problem like this 5 years ago, starting from scratch, would be talk to the person at the very end of the road who's going to use what you're building. So not the business manager, not the technical lead, not the whoever it is who's funding or sponsoring the project in your company. Talk to the man or woman or person at the end of the line with a laptop who's going to take your insight and do something with it. Because if you don't talk to them, maybe you'll get lucky and maybe you'll make something that may be useful to them, but the chances are you're not, or at least you're not going to get as much value out of it that you could. So yeah, have that honest conversation to understand if the thing that you're going to do, the really cool problem that you're going to solve, the really cool tools that exist and you think is a great idea, because data scientists could spend all day playing with things. It's good fun. But if you're not going to deliver something that somebody at the end is going to use, then there's no point. Kind of depressing bit of advice, but hopefully that's useful.
Great, thank you so much. So we've got just under 10 minutes left. Do we have any questions from the audience? I think it's probably easiest if I bring the mic to you. Thank you very much.
Hi Chris, Tiana here from AWS. I'm one of the... Oh yeah, can't hear me, I just realised.
we've hit a technology problem.
Gotta love technology. Tiana here from AWS. I'm one of the account executives. One of the things that I picked up on is you mentioned that Aggreko is looking to minimize its carbon footprint. I just wanted to understand how that currently affects your customer retention and acquisition at this point in time, because of course sustainability is quite a big factor for consumers.
Yeah,
So just wanted to understand how that has affected Aggreko.
definitely. So it's something that, as an analytics capability, we've been starting to build out over the last year or two, but with the view that it's not just a technical problem, it's a commercial problem. So if Agreco are bidding for a project, it's the norm now to put in, if you're one of the companies that Agreco will be competing with, what you're going to do in terms of carbon reduction or emissions reduction. So yeah, it's a tangible thing that we're having to build in to say, this is the composition of the fleet that we could provide you, this is how we're going to justify it, this is how we're going to explain it to you and provide the traceability. And that's definitely a factor, and I think whether you win or you don't win a contract.
Thank you very much.
Were there any other questions? No? No other questions? All right. Well, thank you so much for coming, everyone. Really appreciate it. Thank you so much for that, Chris. It was great to hear more about your journey and what you've been up to. Any other questions? We have Databricks stand. You'll spot the Lake House Theatre just in the middle, so please feel free to swing by. Are you around for the rest of the afternoon?
I'll be here, yeah.
Yeah, so Chris will be around. Feel free to grab him as well, in a nice way. Thank you very much, everyone. Enjoy the rest of the afternoon.
Thank you.